In the realm where ancient Indian knowledge meets modern science, the intriguing parallels between Buddhist teachings on emptiness and the principles of quantum physics offer a profound understanding of the nature of reality. Buddhist philosophy, particularly as it evolved in India, presents the concept of emptiness or shunyata. This principle suggests that nothing possesses inherent, independent existence. Instead, all phenomena arise from a void, an infinite field of possibilities, and are interdependent. This notion implies that the existence and characteristics of objects or beings are not absolute, but are perceived relative to other factors and conditions. Quantum physics, a significant development in modern science, echoes this ancient spiritual insight. The quantum field theory posits that what we perceive as matter emerges from a quantum field, an unobservable field of energy that underlies all physical reality. This field is not empty in the conventional sense, but is a plenum of energy and potential. Particles, the building blocks of matter, are not static entities but arise from fluctuations within this field. Both perspectives, although arising from different methodologies, spiritual introspection and scientific investigation, converge on the idea that the foundation of reality is not a solid, tangible entity. Instead, it is a dynamic, interconnected web of relationships and potentialities. In Buddhism, this is understood through meditation and philosophical inquiry, leading to the realization that the self and the universe are devoid of intrinsic, independent essence. In quantum physics, experiments and mathematical models reveal that particles do not have definitive positions or properties until they are observed, implying that reality at its fundamental level is shaped by observation and interaction. This convergence suggests a universe where the material and the spiritual are not separate domains, but interconnected aspects of a singular, profound reality. The Buddhist concept of emptiness and the quantum field theory both challenge the notion of a fixed, unchanging universe, proposing instead a dynamic, interdependent existence where the observer and the observed are deeply linked. This understanding bridges the ancient and the modern, offering a holistic view of the cosmos that transcends the boundaries of conventional thought. The concept of particle-wave duality in quantum physics is a fascinating aspect of modern science that challenges our traditional understanding of the physical world. This principle, deeply rooted in the field of quantum mechanics, suggests that every particle or quantum entity can be described as both a particle and a wave. Traditionally, particles, like electrons or photons, were thought to be discrete, point-like entities with specific locations in space and time. However, quantum physics introduced a revolutionary idea. These particles also exhibit wave-like characteristics. Unlike particles, waves are not localized in space. They are spread out and can exhibit patterns of interference and diffraction. One of the most striking demonstrations of particle-wave duality is the famous double-slit experiment. When particles such as electrons are fired at a barrier with two slits, they do not create two distinct impact points as one would expect from classical particles. Instead, they form an interference pattern on a detector screen, a behavior characteristic of waves. This pattern only appears when the path of the particle is not observed. If the path is measured, the particles behave as if they passed through one slit or the other, like traditional particles. This experiment implies that the fundamental nature of these quantum entities is neither purely particle nor purely wave, but something more complex and abstract. The dual behavior depends significantly on the observational context. When observed, quantum entities exhibit particle-like characteristics, but when unobserved, they behave as waves. The particle-wave duality also suggests that at a fundamental level, the nature of reality is defined by probabilities rather than certainties. A quantum entity's exact position and momentum cannot be determined simultaneously with precision, as stated in Heisenberg's uncertainty principle. This principle indicates that the more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. Particle-wave duality is a cornerstone concept in quantum mechanics, profoundly affecting how scientists view the physical universe. It blurs the line between the previously distinct concepts of particles and waves, suggesting a more interconnected and less deterministic universe than previously thought. This idea has led to the development of new technologies, including quantum computing, and has deep implications for our understanding of the nature of reality itself. The role of consciousness in reality formation is a topic that intersects the realms of ancient philosophical inquiry and cutting-edge physics, offering profound insights into the nature of existence. In various ancient Indian teachings and modern quantum physics, consciousness is seen as a key factor in shaping the reality we experience. Ancient Indian wisdom, especially in traditions like Vedanta and Buddhism, has long proposed that the world as we perceive it is a manifestation of our consciousness. These philosophies suggest that the reality we experience is not an independent, objective entity, but rather a projection of our mind. This idea is encapsulated in the concept of Maya in Vedanta, which implies that the world is an illusion, a play of consciousness. Similarly, in Buddhism, especially in the Madhyamaka school, the idea of dependent origination suggests that phenomena arise in dependence on causes and conditions, including the cognitive activities of the mind. In the field of quantum physics, the role of the observer has been a subject of intrigue and debate, particularly since the advent of experiments like the double-slit experiment. This experiment demonstrated that particles such as electrons and photons behave differently when observed. When not observed, they exhibit wave-like characteristics, forming interference patterns indicative of a wave. However, once observed, they behave as particles, with each particle passing through one slit or the other. This phenomenon suggests that the act of observation, a function of consciousness, plays a role in determining the state of a quantum system. The implications of this are profound. If the act of observation can determine the state of a quantum system, it raises questions about the role of consciousness in the formation of reality. It suggests that at a fundamental level, the reality we observe is not just passively out there, but is in some way a co-creation with our consciousness. This concept resonates with the ancient Indian idea that the world is a manifestation of the mind. Both perspectives point to a universe where the material and the experiential, the physical and the mental, are deeply intertwined. They suggest that our understanding of reality, far from being a mere passive reception of external stimuli, involves an active process of creation by the conscious mind. The exploration of consciousness in the formation of reality represents a fascinating convergence of ancient spiritual wisdom and modern scientific inquiry. It challenges our conventional views of reality, inviting us to consider a more holistic, interconnected universe where the observer is not separate from the observed, but fundamentally connected in the very act of perception. Quantum entanglement and the concept of universal oneness are topics at the forefront of modern physics, echoing ancient wisdom from various traditions, notably from ancient India. These ideas delve into the fundamental nature of reality and our interconnectedness within the universe. Quantum entanglement is a phenomenon observed in quantum physics, where particles become interconnected in such a way that the state of one particle instantaneously influences the state of another, no matter how far apart they are. This implies that a pair of entangled particles act as a unified system. For instance, if one entangled particle is observed to spin in a particular direction, its partner will spin in the opposite direction immediately, even if they are light years apart. This instantaneous connection challenges the conventional understanding of space and time, and suggests a deeper level of unity in the universe. This concept resonates with the ancient philosophical idea of universal oneness, a core principle in many Indian spiritual traditions. For example, in the Vedantic tradition, the notion of Advaita, non-duality, suggests that all individual entities in the universe are manifestations of a single underlying reality. This reality, often referred to as Brahman in Hindu philosophy, is the eternal, unchanging truth behind all appearances and distinctions. Similarly, the concept of Tat Tvam Asi, thou art that, in Upanishadic teachings implies that the individual self, Atman, and the universal self, Brahman, are one and the same. The parallels between quantum entanglement and these ancient teachings suggest a universe where separateness is an illusion and everything is interconnected at a fundamental level. Quantum entanglement shows that particles, once entwined, lose their individuality to some extent and behave as a single entity, despite spatial separation. This idea mirrors the spiritual teachings that all forms in the universe are interconnected parts of a singular, unified whole. The concept of universal oneness in ancient wisdom and the phenomenon of quantum entanglement in modern science both challenge the perception of the world as composed of separate, isolated parts. Instead, they propose a more holistic view of reality where everything is interconnected, interdependent, and part of a greater whole. This understanding has profound implications not only for physics, but also for our worldview and philosophy of life, suggesting that our actions and existence are deeply woven into the fabric of the universe. The double-slit experiment in quantum physics and its implications on the mind-reality connection present one of the most intriguing intersections of modern science and ancient philosophical concepts, particularly those originating from ancient Indian wisdom. This experiment fundamentally challenges our understanding of reality and the role of consciousness within it. The double-slit experiment is a famous experiment in quantum mechanics where particles such as electrons or photons are fired at a barrier with two slits. In classical physics, one would expect these particles to pass through either slit and form two distinct patterns on the other side. However, the results in quantum mechanics are far more complex and puzzling. When particles are not observed, they behave as waves, creating an interference pattern on the detection screen that indicates they have passed through both slits simultaneously, much like water waves would do. This wave-like behavior suggests that the particles exist in a state of potentiality, in multiple states or locations at once, until they are measured. However, when the particles are observed or measured as they pass through the slits, they behave as particles, not waves. They pass through one slit or the other, not both, and form two distinct patterns, as would be expected from classical particles. This change in behavior due to observation implies that the act of measurement collapses the wave function, the mathematical description of the quantum state, into a particular state. This outcome of the double-slit experiment raises profound questions about the role of consciousness in the formation of reality. It suggests that at a fundamental level, reality does not exist in a definite state independent of our observation. Instead, it is the act of observing or consciousness that brings reality into a definite state. This concept resonates with ancient Indian philosophical and spiritual teachings, where consciousness is considered the primary substance of the universe. In traditions like Vedanta, reality is seen as a manifestation of consciousness, and the material world is considered secondary to consciousness or mind. The idea that the material world arises from consciousness, rather than consciousness being a product of the material world, is a cornerstone of many Eastern philosophies. The double-slit experiment's implication that the observer cannot be separated from the observed parallels the ancient Indian notion of non-duality, where the observer, Atman or the individual soul, and the observed, Brahman, or the universal consciousness, are essentially one and the same. In summary, the double-slit experiment in quantum physics and its implications align remarkably with ancient Indian teachings about the nature of reality and consciousness. Both suggest a universe where the material and the experiential, the physical and the mental, are deeply intertwined, and where consciousness plays a fundamental role in the manifestation of reality. This merging of modern scientific understanding with ancient wisdom offers a holistic view of the cosmos, transcending traditional boundaries of thought.